We are going to see how to add an element in the list of available accessories in the Singular Head Loss Calculation tab. If you have singular head loss coefficients for a given accessory, you can create a new element using the element editor. The items you create are placed in the miscellaneous items category. Here we see elements that have already been set up, available in the miscellaneous elements category. Let's now see how to create a new element from a load loss chart. We will see here, for example, how to create a new element according to a table of parameters and pressure drop coefficients. Here we have head loss coefficients, given as a function of two main parameters: the ratio, lateral flow to main flow, and the second parameter, the ratio, lateral section to main section. We therefore have the pressure drop coefficients depending on these two parameters, and also a diagram which allows us to visualize these parameters. We are going to use this diagram to make a synthesis of the parameters and a reminder of the conditions of use of this element. We are modifying the diagram to reflect all these terms of use. Here the diagram shows the terms of use. With this diagram and this table of load coefficients, we will create our element. We select the function, create an element with the element editor. The interface of the element editor appears. It allows us to create elements. Element creation is done in 4 steps. In the first step, we name the element. Current meeting 45, superior. And we go to the next step. At this step there, we will indicate the number of parameters and the name of its parameters. We have rendered an array of coefficients that we have 2 parameters. We therefore select 2 parameters, and we name these parameters. The first parameter is the side flow to main flow ratio. And the second parameter is the side section to main section ratio. And now we are going to enter the value for each of these parameters. So here I have the values of the first parameter vertically on the table. I enter the value 0.1, which I add to the list of values for the first parameter, and so on for all the values. Here, we have entered all the values of our vertical column corresponding to the first parameter, and we enter the values of the second parameter, which are on the horizontal line at the top of the table. This being done, we will move on to entering the pressure drop coefficients. We are at step 3 out of 4, entering the load factors. So, according to the load table, so for this we have a method which allows us to enter each coefficient and check each combination of parameters. If sometimes errors are inserted, we can correct the item file later. I deliberately omitted the 0 value of the first parameter, which will never be used by the software user. We start entering at the point of intersection of parameters 0.1 and 0.1, which gives a pressure drop coefficient of 0.05. I therefore enter the coefficient 0.05. I click on Save the coefficient. I have a small message which asks me to confirm the recording. And in this text zone appears the last combination recorded. When I clicked on Save the coefficient, I moved to the second line. So to the respective values of the two parameters of 0.2 and 0.1. And I therefore enter the coefficient for this combination of values, which is equal to minus 0.2. And I save the coefficient, and so on, until all the parameters have been fully entered. It must be said that this element has a lot of coefficients. We could have taken an element with fewer lines. We arrive at the end of the input, at the last combination of parameters, so with a coefficient of minus 0.42. When we reach the end of the entry, we have an end of entry message that appears. It remains to choose the image that will represent this element. I'm using the element schema. Assign this image to element and save. And voila, our new finished element. It is now available in our tab, Singular Head Losses. We find the two parameters. To use this element, we enter the speed of the fluid, which is taken according to the diagrams in the main part. We estimate that it is 10 meters a second. Here we have to enter the section of the element. Why? We could do the calculation without this section. But if you want to do a test of the inventory of the pressure drops at different flow rates, the software will have to recalculate the pressure drop coefficients. And for that, the software needs a section refresh speed. So here, a small tool that calculates the section, depending on the diameter. For a diameter of 100, we will apply this section. We can calculate the pressure drop. We choose a fluid air at 20 degrees. At atmospheric pressure, and the pressure drop is calculated. The calculated head loss is here. In the head loss inventory, the line shows the name of the element. We have the diameter and head loss coefficients of 0.05, which corresponds well to the parameters 0.1 and 0.1 from our table. You have seen that creating a singular element can take time if there are many parameters. But if you have singular elements whose parameters are similar, you can go directly to the file of the element, copy it and modify its parameters. So we will see the file corresponding to an added element. This is useful if we want to delete the element, or modify some values following errors, or all the values, to create a file derived from an element. So we open the Windows Explorer, and we go to the file, Program Files, x86, Mekaflux, Singularities. This Singularities folder contains all the various elements. The singular elements are defined by two files, a file with a .sin extension and a file that corresponds to its image, which is in JPEG or another format. It is the one that appears in the software, here. If I modify this image, I will also modify it in the software. But you can also change the values, pressure drop coefficients or parameters. For example, we will open the file, which represents our singular element. With Notepad, here is the file that represents the data of our element. The different parameters, the number of parameters. Here there are 10. For each of the combinations of the parameters, we have the pressure drop coefficient which appears. This is what we entered earlier. So if we wanted to create a similar file, which would have the same parameters, we could go and modify the pressure drop coefficients one after the other, to avoid too long an entry. Afterwards, this file should be saved under a new name, and also a new image created with a new name. So we can derive elements using this method. If now I decide to delete this file and its image, it will no longer appear in the list of miscellaneous elements of miscellaneous pressure drop coefficients.